So, today I will discuss about the LR circuit, series LR circuit. So, this L inductor and this resistor R. So, these two are in series. This is the AC power supply, this is the AC power supply. Okay. So, now AC power supply. So, if you start from one terminal and it should go through this R and the L and then come back to the other terminal. So, then it is a L R is in series. Okay. So, if we apply some voltage with some frequency, then there will be current in this circuit, AC current in this circuit with the same frequency, and there will be voltage drop across the resistance and across the inductor. So, this voltage drop is across the resistance is VR and across this inductor coil, so that is VL. Okay. So, then basically this current in this circuit you can find out I equal to VR by R. Okay. So, same current will flow through this circuit, through the R as well as this conductor, inductor, right. So, current in this circuit, if I can find out if I measure the VR and if I know the R, then from there I will know the current in the circuit for a particular frequency. Now, if you measure the voltage drop across this coil, so that is VL. Okay. So, that VL is equal to square root of small r square plus xl square. So, what is small r? Small r here we have shown separately. It is the basically resistance of this coil, inductor coils. So, and this xl is the reactance, inductive reactance, a resistance equivalent to resistance, inductive reactance, this is xl. Okay. So, this the impedance of this inductor basically the square root of r square plus xl square. So, this is the equivalent to resistance, impedance, this equivalent to resistance into I. So, that will be the voltage VL. So, I can measure the voltage VL and current I will get from here, okay, I. So, then I will get this value r square square root of r square plus xl square, impedance value I will get. Okay. So, that impedance ZL we can write ZL equal to VL by I equal to square root of r square plus XL is omega L. So, that is 2 pi FL. So, this 4 pi square F square L square. So, impedance equal to this, right. So, now this as I told for a particular frequency. Now, for frequency say F1, so this impedance is Z1 is square root of r square plus 4 pi square F1 square L square, and if then you change the frequency to F2 for second frequency. If you so this impedance will be square root of r square plus 4 pi square F2 square L square. Okay. So, if you so basically so you have two equation, Z1 equal to this and Z2 equal to this, or square of Z1 equal to r square plus 4 pi square F1 square L square, and square of Z2 equal to r square plus 4 pi square F2 square L square. Now, if I measure, as I told, if I measure this VR and VL, and if I know the resistance R, then I know the Z value. Experimentally, I know the Z value, right? I know the Z value. So, this Z value experimentally, Z1 and Z2 I can find out. I can find out from this relation for a particular frequency F1 and F2. Now, F1 and F2 also known to me. So, unknown is this small r and this L, resistance of the coil as well as the inductance of the coil, these two are known. So, I have two equations, two unknowns. If I solve it, then I can find out R and L. So, that is why just if you solve it, L equal to 1 by 2 pi square root of Z square, Z2 square minus Z1 square divided by F2 square minus F1 square, and R small r equal to 1 by 2 pi square root of Z1 square F2 square minus Z2 square F1 square divided by F2 square minus F1 square. Okay. So, F1, F2 is known, Z1 and Z2 we have to know. So, that I will know if I measure, I will know Z1, Z2, I will know if I measure VR and VL. Okay. So, to determine the inductance and its resistance, okay, in this circuit, series LR circuit, so what I have to do? I have to measure the this VR and VL for two different frequencies. Okay. So, then I can determine this. Okay. Also, in other way you can think that keep a particular frequency F1, and now you take reading of VL varying the current I. So, how you will vary the current I? You just vary the voltage of the source voltage. So, vary the source voltage and take the reading of VL. Okay, take the reading of VL. So, you take few data, okay, 5, 6, 7 data you take for few current you take this VL, for few current you take VL again for another frequency F2. So, then you plot them, VL versus I for a frequency F1. So, you will get a straight line and slope of it will give you Z1, and slope of this one for frequency 2. So, slope of this one will give you Z2. So, Z1 and Z2 from this graph you can find out. Okay. And F1, F2 of course is known to you. So, basically you will get I measuring the VR divided by this resistance. So, it will give I, and VL you have to measure across this one. So, basically ultimately we are measuring the VR and VL as a function of I. Also, you can measure VL and VL and VR as a function of frequency. As a function of frequency, so this is the relation. As a function of frequency, if you measure VL and VR, of course, from here you will get I, from here you will get I, and VL, then you will get VL, different VL for different I, and then basically VL by I will give you ZL. So, you will get ZL. So, for different frequency you will get this Z impedance, right. Now, so you are collecting the data varying the frequency, and you are taking reading for different frequency, you are taking reading VR, corresponding I and VL, okay, and from there you will get this impedance. So then you can plot graph impedance versus this current. Impedance versus current if you plot. So what will happen, this XL, this value, this part XL, this value depends on F. For higher frequency, this XL value will be higher, okay. So lower frequency, this part will be smaller, okay. So this value may be comparable with this internal resistance of the coil, right. So but for higher frequency, in kilohertz frequency, this value, this XL will be very, very high compared to this resistance, right, compared to this internal resistance. So then you can ignore, basically at higher frequency you can ignore this R, smaller resistance, okay. So if you want to find out just this XL, if you want to find out the if you want to find out the measure only inductance, then you can do the experiment at higher frequency, and in higher frequency you can ignore this R, then you just plot Z versus this F. It will be a I think yeah. So whatever variation, it may not be straight line because the F square are there. So at higher frequency, if you ignore this one, then it will be straight line. So so there will be variation of Z, and then if you take gradient, of this curve, then from that gradient basically you will find out the L value, okay. You will find out the L value because F is variable, F and Z. So you will gradient will be basically 2 pi L. Gradient will be because square root will go, this R square is, so it will be basically 2 pi FL, okay. So ZL equal to 2 pi FL. So if you plot graph ZL versus F, so slope of the curve will be 2 pi L, okay. So finding out the slope, you can calculate the L, okay. So this way also you can find out just inductance, okay, inductance. So for that you have to do experiment at higher frequency. Of course, to see the variation, of this impedance, you can do the experiment for whole range of the frequency and take the slope at higher frequency. So directly that from that slope you will get this 2 pi L value. So from there you can find out the L, okay. So here just I will show you this what is the setup and how to do the experiment. I will just show you. So this is the experimental setup, okay. So this is resistance R. So this resistance R is a 2 ohm, resistance, and this is our inductor. This is our inductor. You can see the coil, right? Inductor coil you can see, okay. So it has option of 100 turns, 250 turns, 500 turns, okay. So we have taken here for 100 turns. So again you can vary L also, So for 100 turns, whatever L, for 250 it will be different, for 500. So varying L also you can repeat the experiment, but I will show just for 100 turn. So it will have I do not know exactly what will be the inductance, but it will be around 1 millihenry. But experimentally we want to find out what is the inductance of this 100 turns coil, and what is the internal resistance of this 100 turn coil, okay. So that is the experiment we want to do. So now I have to make it series circuit. So this is the power supply. AC power supply, you can change the amplitude as well as frequency of this of the voltage. Okay. So, this voltage will be, so this is the voltage source, okay, AC source. So, one terminal of this source is connected to the resistance, and then other end of the resistance is connected to the inductance, here inductance, and then other end the inductance is connected to the other terminal of the voltmeter, volt source, okay, power source. So, with power, this L and R are in series, okay. So, from here I can choose the voltage, means amplitude as well as the frequency. Now, what I want to do? I want to measure VR and VL. So, I have taken two multimeters. So, we will use this multimeter in I think in voltmeter mode, okay. So, and also it has both option AC and DC, so you have to take DC mode, AC mode, okay. So, this voltmeter is connected across this resistance, right, across this resistance. So, it will give me VR, and this voltmeter is connected across the inductor, I think, yes, across the inductor, this voltmeter is connected to the inductor, okay. So, this voltmeter will give me the voltage VL across this inductor L, okay. So, let me switch on this voltmeter, power on of this one, yes, and this should be in AC mode. This power is on now and it should be in AC mode. So, this AC in volt, this 2.0 volt, 04 volt it is showing. So, this also I have to switch on, this also I have to switch on, yes, this I have to switch on, and it should be in AC mode, it has to be AC mode, okay. So, okay. So, here this meter is showing this is 1.263 volt, it's written volt, and this is 2.04 volt, okay. So, this voltage drop across this VR and this is VS. So, here this let us check what is the voltage amplitude we have given and what is the frequency. Right now, frequency I can see this is 10, this I can see this is the 10 hertz. So, 10 hertz, and I think I have given the amplitude here, it is 10 volt, 10 volt amplitude we have given. Now, here it is not actually 10 volt, the AC peak to peak value, it is showing AC amplitude. So, peak to peak value. So, then you have to divide it by 2√2, then it will be RMS value. So, RMS value, so divide by 2, that is 5, 10 divided by 2, 5, then 5 divided by √2. So, if you calculate it will be around 3.4, okay. If you calculate it will be around 3.4 volt, and yeah, around 3.3, 3.4 volt. Now, so this source voltage, it should be equal to the voltage drop across the resistance and voltage drop across the inductance, okay. So, VL plus VR, it should be equal to VS. So, here this is VR is 1.3 approximately, and here it is 2.1 approximately. So, 3.4, okay, approximately 3.4, and RMS value of 10 volt peak to peak value, this is divided by 2√2, 10 divided by 2√2, it is also around 3.4. So, this way you can check this our circuit and connection is alright, it's fine. So, let us now do the experiment. What we want to do? We want to do experiment this, we want to measure the VR and VL varying the current. So, how I will vary the current? I will vary the voltage, and I will take the reading. So, since it is at already in 10 volts, so you should go to the lower volt first. Let me start with, so I am changing, you see, I am changing the voltage here. So, now here this reading are changed. So, you should change this voltage. So, let me go to the lower value first. Let me go to the lower value, say 5, let me go to the 5 volt, okay. So, at 5 volt, note down then this source voltage is peak to peak value 5 volt, and then corresponding this VR is 0.63 volt, and this is 0.98 volt, VL is 0.98 volt, okay. Now, this is one reading, then you take the second reading, I will change by 5.5, then you note down this 0.69 and here 1.08, okay. So, this way just you vary, then go to 6, go to 7, go to 8, go to 9, up to 10, okay. So, you will get 10 reading. So, for 10 reading you will get VL and VR. So, you will R here, you should note down this R is 2 ohm, capital R is 2 ohm. So, this VR by R, this will give you I, okay. So, now I will plot I. So, this measurement I have done for a particular frequency, okay. What was the frequency? I should, yes, I should see the frequency. It's I have done this experiment for 10 Hz, okay. So, for 10 Hz frequency, I have VL versus I data. I will plot it. Then its slope will give you, say, Z1. As in theory I mentioned, it will give you the Z1, right. Then I will go to the second frequency. At lower frequency is fine, say I will go to 100 frequency, 100 Hz, okay. Now, in 100 Hz, again I will vary the source voltage, it is, let us start again from 5, okay. So, now at 5 source this peak to peak value, so I will note down the VL and VR. So, VL it is again 0.98 and it is 0.61. I do not know, there is no mass change, let me check it, it may not be because it is let us see. Now, I change the voltage and then I should note down this change, okay. So, if you see this change is not much, okay, slope is almost similar, then you take higher, I have taken 100 Hz, so you take 300, 400 Hz, okay, of frequency and do the experiment, that one should check, okay. So, this is for second frequency, again I will change the source voltage and I will take reading of VR and VL. So, so from VR I will get I, VR divided by 2, resistance, capital resistance R is 2. So, so I will get I versus VL for second frequency, okay. Again I will plot it and I will find out Z2. Now, if you know Z1 and Z2 as I showed, if you know the Z1 and Z2, okay, Z1 and Z2 and F1, F2, these two curve F1, F2 also you know. So, you can calculate L and R, okay. So, as I told, you can do the experiment as a function of frequency. So, same way how to change the frequency, just in that case we will set a particular voltage, say we will particular voltage, let me go to the volt, say 10 volt we will set at 10 volt, peak to peak 10 volt, okay, 10 volt I set. Now, I will vary the frequency, say I will start frequency 10 hertz, okay. Now, I will change the frequency and note down the VL and VR. So, from VR I will know the I basically. So, VR I need for knowing the I. So, basically VL versus I that I think here frequency, we are changing frequency. So, so what I want to do? I want to vary the okay, at higher frequency, as I told, at higher frequency this will be higher and this I can ignore, okay. So, Z will vary, and RL will vary. So, basically what I will do, I can vary the frequency, and with that how this impedance changes, that we can find out, how impedance changes, that we can find out. So, measuring VR and VL, you can find out the impedance. So, impedance versus this frequency you can plot. If you plot at higher frequency side, whatever the curve, at higher frequency side, whatever the curve, from there if you find out the slope, then no, I have to, at higher frequency I have to find out the slope. That means I have to plot VL versus, just I am confused. So, I want to find, okay, fine. So, this Z will be equal to, if you ignore at higher frequency, if you ignore this one, the 2 pi FL, okay. So, now if I plot Z versus this frequency, Z versus the frequency, if I plot Z versus the frequency, so generally this type of curve will get, okay. So, at higher frequency, if I take the slope, I will get basically Z by F, okay. So, Z by F is basically will be 2 pi L, okay. So, the slope will be 2 pi L. So, from there you will find out the slope by 2 pi, okay, that will be the L. So, doing this experiment, just varying the frequency, you can note down the VR and VL, okay, and then basically from there you will get this impedance. Impedance is equal to VL by I will get from here, and VL you are measuring, so this by I, so the ZL. So, I will plot ZL as a function of F, and now at higher frequency side, if you take slope, and from that slope you can find out the L, okay. Also you can see the variation of the impedance as a function of frequency, okay. So, this is the experiment, simple experiment, but this LR, CR, LCR, this circuit have very importance in electrical instrument, okay. So, these are the basic understanding of this type of circuit. So, in future, in many places you will use this type of circuit. So, I think I will stop here. Thank you for your attention.